here, I guess. Yeah.
So, transportation. We have come so far from just driving the wheel along the way. But I personally think that the ultimate goal is to have completely remote and autonomous drive. And I don't think that I'm very satisfied with the current condition of autonomous drive. So in this project, we are trying to do one thing. Currently, the issues that we face is that whenever an autonomous car comes along the conditions which were not predicted or were tested on the model, then it does not know what this is actually doing. And sometimes this may cause some critical failures, even result in fatality. So what we are trying to do in this project is build up on all the various scenarios that the driving environment are there, all the extreme conditions, all the different elements in the model, and the way of doing that is using advanced sensing mechanisms, Lidar being the most prominent of them. Now we can even use image processing, take some pictures, but the main disadvantage of using image capturing is that first we'll get only a 2D image, so we'll need more than one camera to know what is the depth of the object. And also, if you calculate pixel by pixel, so an image, if you take an image, it has a lot of redundant data. But a LiDAR sensor, it only detects the objects that are there. Now it's in the functioning of the LiDAR sensor. So what it does is it throws laser points, and it takes how much time it takes for the laser beam to reflect back from the object. And so we only detect the objects that are necessary and not the environmental factors like sky and the in between areas or something. So we get like more than 50 times we decrease the size of the data by more than 50 times. So if we want to cover say one city, then the data set collected by the LiDAR sensor will be way more smaller than the one collected by the camera. This might not seem a lot, but I think it is really advantageous when you want to take real-time decisions and we want to process the data as fast as possible. So LiDAR is definitely the best choice in that. Specifically, we are using the Ouster OS1 model because it is like the leading sensor in the industry of LiDAR sensor. It has 128 individual channels like this, and each of those channels have a sensor array. There's a transmitter, receiver, area of those. And what we are detecting basically is the time that the laser beam takes to reflect back from the surface. Also, we are calculating the intensity of the light. So that way we know what is the reflectivity of the surface, and it helps us to classify whether it's a light pole, whether it's a lane on the road, or it's just the road surface. And that is sort of where the pre-processing part comes in, and we do that by a model called semantic segmentation. And it is just the thing that it sounds like. So we are trying to differentiate between the actual LiDAR data would consist of a lot of points, but none of them would be colored. All of them would be just gray points. So what we are trying to do is classify those objects based on pre-existing training. So what semantic segmentation does is it converts the LiDAR point cloud into defined objects like light poles, lane markers, the road, those sort of things. And we colorize it just for our visualization purpose, but the main aim is to classify. And once we have pre-processed the data into different classes, then we'll use the transformer V2 model. And this is where the research part is ongoing. So we have currently had like the best success rate so far in this field. There is 70% accuracy in identifying whether the data that we are getting is the road, what part of the road it is, what is the lane width. So that is the transformer V2 model. It uses deep learning models and machine learning algorithms to identify the different classes that are, and I mean whether it's a traffic sign or those sort of things. And based on that, now we will be working on converting the data that we get from this to NLP. So NLP is like you might have heard of ChatGPT. It's called natural language processing. So it converts the data back to a form that the user or the machine can understand. So the main goal is to help the autonomous driving models to better infer what the road conditions are, what is the terrain like, and to make the model more dynamic and not just like go ahead and stop it if any obstacle comes. What is the best way to get around? So it is sort of the idea.
Very cool.
this has answered a lot of my questions just by trying to scan this through as you're speaking about it and bringing this to life. My first question was to think, where was this invented?
Oh, it is made in the US. The out, you mean the
Yeah, I guess like the technology, this, because this is the OS1 model of the ouster lidar sensor. Was this invented at a particular institution, or was it?
No, it's the Ouster is like a company that is selling the lidar sensors, and they made this. I mean, the lidar sensing goes way back into the 19th century, but the sophisticated use of like an array of sensors and then 120 channels. So this sensor alone can cover like 360 degree of the horizontal surface and 45 degree of the vertical surface, because there are sensors on the horizontal panel and the vertical panel. So you get almost semi-sphere of complete coverage within the and right now not a lot of people are using it for the way we would collect data, that is like strapping it on radar. The most prominent use is like attaching it to a drone and then getting the entire view of the street. So we can monitor a lot of data. And it takes 5.2 million samples per second. So that is 5.2 million individual points. And that is its capacity, but it will depend, like, does your environment even have that much space to have 5.2 million points?
Yeah, like when it comes to the storage of all this data, what type of server farm would you need to support like keeping all of this?
For the LiDAR data, it actually just stores the values of, so there are four values: the intensity, the wavelength, the distance, and the time it took. So those four values are hardly 1 by 2 bytes per sample. So we can very easily store it locally. But for the ouster, they are also providing the database system that it would in real time just upload it over 5G to their online database.
Gotcha.
And
Okay, so
then,
it goes up into the cloud of like this the private.
Yeah.
Gotcha.
Exactly. But we are trying to make it more open source, so we have collaborated with one more software company. It's called Bitland, and we are trying to not use the software that Austra is providing, because they charge money for using their software, and we want to make this more accessible to the people. So we are building the software by ourselves, and we'll make it open source for people to use.
Wow, that is incredible. Cool. Truly, this you were able to frame it in a way that simplifies it enough for somebody like myself to understand who doesn't have a background in engineering or really any of these specialized tools, but to put it into a way that we can all understand and that really truly paints the picture. I was wondering, hey, how does it distinguish between, is that just a bushel on the side of the road, or is it an actual purpose-built, human-made feature of some kind that, or is a marker of something, or is it something to be aware of? But the fact that there's these models to be able to kind of parse through.
These results are from the previous database that was collected. These are not like, we are still working on the sensing technology to get more and more data. But this data set was like, somebody had to sit down and individually mark the segments and say that like this is the lane, this is, because there was no existing data on it. This is like the first project in this course. But now that we have done that training, we can use that model to build upon that and use way larger data sets to get that done within seconds.
Well done. I'm very, very excited to hear how this project has been going and the type of proprietary, whether it's the technology being used to gather the data or to then actually, I guess, go through and make sense of it is really cool to see how the technology can impact the future of autonomous vehicles. Alright, nice. Thank you so much. Appreciate hearing more about your next work. It's wonderful. So cool.
I am from VIT There would still be some issues with actually implementing autonomous driving, which are not in the field of technology, but more in the field of law and psychology, because people do not trust the autonomous vehicles so much, especially since the last December, because the Teslas have had some crashes, and since then it has become mandatory, at least in the state of California, if not first we used to have someone actually holding the steering for the car. But I think like with some time people will get more and more confident.
Yeah, and this is focusing more on the built environment and the permanent kind of static data, the width of the lane of the road and the things along the side of it, and trying not to crash into those. But in a way, the amount of years that we have to try to log and try to get enough data to start making decisions out of this, the much more difficult thing is probably the humans in the vehicles around the autonomous vehicle and trying to react to what just is not nearly as
Predictive.
predictable. Yeah.
The best way I can see is like all of the cars are autonomous. So they would work within like a big cloud data network, and all of them are connected in a big integrated IoT. So the decision making and everything is like it's like a swarm of drones. Everything works with relation. Even for that, you would have to have like complete autonomous driving for everyone also.
It makes me wonder if maybe we'll get to a point where in the core of a city or like the downtown area, if you could have that just be autonomous vehicles in that zone, then because we're like the most unpredictable thing are the humans driving beside the autonomous vehicle. Like they're doing their thing, they've got all the data to prove it, and then the human beside them does something that is just irrational, unpredictable, makes no sense. So where it's a really interesting conundrum to be in, where this is kind of the hard. This is
I mean, Tesla is also working on a project that is going to replace the truck drivers. So what it does is it creates a train of trucks, and the first one is working on autonomous trains, but the rest of them are just following the first one. That is, if we could make like that sort of technology, people want to go from one direction to another. They would have their own car, but all of them would work on a sort of connected way. So that might be something to be done practically.
yeah, very cool stuff. Awesome. Well, thanks for telling me more about it.